For nearly 4 months, the sun did not rise. And somehow, dinosaurs were still there. I'll be honest, when I first read the research on this, I didn't fully believe it. Dinosaurs are supposed to belong to warm, sunny landscapes, not a place where night lasts a season. But by the end, you'll see why scientists call this one of the strangest survival stories in dinosaur history. But around 70 million years ago, northern Alaska tells a different story. Back then, it wasn't the white frozen desert we know today. It was a forested world cut by rivers and floodplains. Plant-eating dinosaurs moved through the trees, smaller hunters followed them, and even a tyrannosaur lived this far north. Then winter came. The temperature dropped. Plant growth slowed. And daylight faded, then disappeared completely. Now, if you were trying to explain how dinosaurs survived a place like this, the easiest answer would be migration. Leave before winter, come back when the sun returns. For a large adult dinosaur, that actually sounds reasonable. Then scientists found something that broke that explanation completely. Baby dinosaurs. Tiny teeth, tiny bones, remains from animals that had only just hatched, and not from one species but from several different groups, all reproducing in Alaska's Prince Creek Formation. That single detail changes everything. Because here's the problem, an adult can travel a long way, but a hatchling can't simply keep up because winter is coming and eggs take time to develop, time the short Arctic summer doesn't really offer. So think about the schedule this would require. Adults arrive, lay eggs, wait for them to hatch, give the young time to grow. Then the entire population has to move far south before winter locks the door. As an explanation for an entire ecosystem that starts to fall apart. Which is why researchers now argue something bigger. Most, and possibly all, of the dinosaurs in this ecosystem were likely year-round Arctic residents. Many of them probably never left. And that's where the real mystery begins. How do you survive a winter you cannot simply escape? First, let's fix the picture in our heads because it's probably wrong. This was not the modern Arctic. At roughly 80 to 85 degrees north, this land supported forests, ponds, rivers, and wetlands. Winters still fell below freezing, snow was possible, but this was a cold, forested world, not a lifeless block of ice. That makes the cold easier to understand. It doesn't solve the bigger problem. Because a warmer climate does not make the winter sun come back. At this latitude, the region still went almost 4 months, roughly 120 days, without a single sunrise. The real danger here was never the darkness itself. It was what darkness did to the food. During the bright months, the Arctic was surprisingly productive. Long summer days meant plants had light for most of the day, herbivores fed well, and predators followed. It was a food chain running at full speed. Then winter shut the whole system down. Fresh leaves became scarce. Growth slowed to almost nothing. The landscape was still there, but the easy calories of summer were gone. Put yourself in the place of a large plant eater. You don't stop needing energy just because the sun disappeared. You still have a massive body to maintain, and if you're young, you're still trying to grow on top of everything else. This is where the fossil record gets frustrating. It tells us these dinosaurs lived here, not exactly what every species ate in the darkest months or how far each herd traveled to find it. But we can see a few ways survival may have been possible. Size was one advantage. Large bodies lose heat more slowly, and big animals can store more energy, giving more room for error when food gets scarce. Movement probably mattered too. Staying in the Arctic didn't mean standing in one valley all year. Herds could shift between river plains, forest patches, and sheltered zones wherever food was reachable. Year-round resident doesn't mean never moved. But movement only helps if your body can actually keep working in the cold. And that's where this stops being about weather and starts being about biology. Polar dinosaurs are one of the biggest reasons the old picture of dinosaurs as simply oversized reptiles doesn't hold up anymore. These animals lived through freezing periods, occasional snow, months of darkness, and massive seasonal swings. We already know some theropods had feathers or feather-like coverings that reduce heat loss. Could Arctic theropods have had something similar? Very possibly. Can we say every dinosaur wore a thick winter coat? No, a good story has to resist becoming better than the evidence allows. Now look at the predators. One of them was Nanuqsaurus, a tyrannosaur known from the Prince Creek Formation. Other meat-eating dinosaurs were here too, and predators tell us something a temperature chart never could. A predator can only survive where prey survives. So this wasn't one unusual dinosaur clinging on at the edge of the world. The fossil record points to a functioning community: herbivores, carnivores, juveniles, breeding populations. The Arctic wasn't just a place they passed through. For many of them, this was home. Okay, here's the part that actually kept me up thinking about it. The fossils I keep coming back to are still the smallest ones. The babies. An adult had advantages a hatchling didn't: more reserves, more efficient heat retention, room to absorb a bad week without dying from it. A hatchling started with none of that. Small bodies lose heat faster, young animals carry fewer reserves, and they need food not just to survive but to grow while the clock is already running. And in the Arctic, they were growing against a deadline. Winter was coming, ready or not, and that's exactly why the timing of reproduction becomes one of the most important pieces of this whole puzzle. When the sun returned each spring, the entire ecosystem flipped. Plants began growing again, days stretched impossibly long, food became easy to find. For a young dinosaur, those months weren't just nice weather. They were preparation: hatch early, feed, grow, build reserves. Every extra week before winter could be the difference that mattered. Suddenly, the whole Arctic year starts to make sense. Summer wasn't just the opposite of winter. It may have been what made winter survivable. Survival here probably wasn't about one dramatic adaptation. It was about timing the entire year around a closing window. Now hibernation is a tempting idea here. Months of darkness, falling food, dropping temperatures. It sounds like the obvious answer. Maybe some species did slow down. That's genuinely possible. But we don't have strong evidence that this entire community simply shut down and slept through winter. And honestly, we don't need that explanation for the fossils to make sense. A warmer-than-modern climate softened the cold. Large body size helped conserve heat and energy. Insulation may have helped certain species. Local movement gave herds access to better feeding ground, and a productive summer let animals build reserves. Reproduction timed to the brighter months gave the smallest, most vulnerable dinosaurs a real chance to grow before conditions turned. That might be the real lesson hiding inside these fossils. They didn't beat winter with one dramatic trick. They lived inside a system that gave them just enough light, just enough time, just enough food before winter arrived again. Picture that Arctic forest one more time. The sun hasn't risen in weeks. No endless wall of ice, just dark conifers over a cold floodplain, a river cutting through the silence, snow lying in patches, fresh growth hard to find. Somewhere in that darkness, a herd is still moving, a predator is still searching, and somewhere nearby, a young dinosaur is living through its very first winter. We'll never know exactly what that animal did each night, or how far it walked in the dark. Those details are gone forever. But the animal itself left something behind, and that's enough to break the easiest version of this story. So how did dinosaurs survive months of polar darkness? Probably not because the Arctic winter was harmless, probably not because every dinosaur simply fled south, and almost certainly not because of one strange adaptation. They lived in a warmer-than-modern Arctic, still dark, still seasonal, still demanding. Different species likely leaned on different combinations of size, insulation, movement, feeding, and timing. The goal was never to make winter easy. It was to survive long enough for the light to come back. And eventually it did. After months below the horizon, the sun returned. Plants started growing again, food became easier to find, and the same landscape that had spent winter squeezing the food web suddenly opened back up. Abundance, preparation, scarcity, survival. That cycle might be the simplest way to understand how dinosaurs built a life this far north. But the detail that actually changes this story isn't the Tyrannosaur. It's the baby. An adult fossil proves a dinosaur reached the Arctic. A baby fossil proves something bigger. For some of these animals, this wasn't just somewhere they passed through. This is where life began. Because sometimes the smallest fossil changes the biggest story. If this is the kind of science you enjoy, where the obvious answer is only the starting point and the fossils get the final word, then please subscribe to this channel. It genuinely helps us keep making videos like this one. Tell me in the comments, do you think these dinosaurs were tougher than we give them credit for? I'll see you in the next one.